In episode 5 of Mobycast, John and Chris make the business case for implementing Docker into your organization. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
Here I am again with Rich and Chris. I guess we can start. Let's just start by talking about what we're working on this week. What have you been up to this week, Rich?
Yeah, so we've been working quite a bit lately on building headless WordPress apps. And so we're wrapping up a project that uses Vue on the front end and WordPress on the back end to create a career builder, which is pretty cool. So most of my time has been spent trying to push WordPress in odd and different directions. But that's pretty much it.
That sounds good. How about you, Chris? What have you been up to?
I have been super busy helping out the team push a big build, a big release to production. So we did a lot of great work in a very short amount of time. And now we're all working hard to stabilize that and get it solid so we can deploy to production.
Also good. We definitely need that at Kelsis. So thank you for that. And I think I can't even remember what I've been working on. Maybe 100% getting ready just for this podcast right here. Given that, so this week we thought we'd talk about building a business case for doing CI/CD with Docker, basically changing your entire software development process to put Docker in the middle of it and build a robust CI/CD pipeline based around Docker. And we wanted to talk about this because a lot of the benefits that get thrown around about Docker are maybe a little bit too hard to understand for the people making financial decisions in companies. So how can you get them to essentially release budget or let velocity slow down a little bit while you decide to implement this? How can you convince them that it's a worthwhile thing without their eyes glazing over? So that's what we'd like to talk about this week. And the challenge for us is going to be to keep out of all the technical jargon and keep it focused on things that the financial decision makers at a company could understand. So in order to get started, I thought we'd just talk about one of the things that would be the easiest sell for any company. So if you can make a case to the people at your company that the problem that you're having with the development team is that feature velocity has grinded to a halt. And if we do this, if we put in Docker and we build this stuff, build the CI/CD pipeline, that feature velocity is going to go back to what it was, and we're going to stop losing all this potential value that we're losing right now because we have horrible feature velocity. So that would be the easiest business case in the world. If you can promise that, then no financial decision maker at any company would say, no, we don't want that. They would all just immediately say yes, and you don't even have to put numbers to it. So let's try that. I thought maybe the way we could try that is by talking about our own past and talking about some times in our past where we've been working on teams or even running teams and seen feature velocity go to zero, and think about, with those times, would a CI/CD pipeline with Docker have fixed the problem? So, Chris, do you think you could give an example of when this has happened in your past?
Sure, absolutely. So one example that immediately comes to mind is this is definitely a few years back when the CI/CD tool set was definitely not nearly as mature as it is right now. There were some tools out there, but pretty primitive. And I was building it was a website and various associated daemon services to do various background tasks. It was all written in .NET and lots of different components and many lines of code. And developing the code and getting the features in there was not necessarily too much of an issue. But what was a very big issue was when it came time to deploy this from somewhere other than my development machine. So there was very much a manual process. So running tests, very much a manual process. Once I was convinced that the code was solid, then it meant I had to package up a release, right? And so that meant compiling source code, building the binary assets, then copying files that were static assets, make sure everything is in the right locations, build up a zip file, then do things like FTP to the servers where the deploy is happening, stopping services, unzipping file. It was literally just, pack your lunch. This is going to be an all-day affair, and also quite risky. So doing the releases was always one of those things where it's like, I know this is going to take a while, and sometimes you end up in a position where you just don't have the time to do it. So these releases get pushed out. So definitely ran into that issue on that project. If I had kind of a CI/CD pipeline in place, like obviously all this time and effort would not have been spent, and it would have gone a lot faster, and I would have appreciated it.
Yeah, that sounds like it would have been a really easy thing to convince. Well, I guess you were your own boss, so you could have convinced yourself to do it a different way at that point.
Yeah, it's interesting. It was kind of a catch-22 because that was a smaller company. It was a bootstrap company, and did not have a lot of development resources. So it was always one of these situations where, can I actually carve out the time to make the investment to improve my tooling so that these things go faster, or do I just do it? So it always came down to that calculation. Do I want to spend 20, 30 hours building the tooling, or do I want to should I just go ahead and spend the 4 hours to get this done? And usually the answer was, yeah, I'm just going to muddle through it and get it done because I can't afford the 20, 30 hours right now to do it.
Sure, makes sense. And I can definitely relate to that with some of the situations that I've been in as well, especially with bootstrap companies that I've done. I have another example. I worked for a company called Store Perform in the early 2000s. Also, Brad Swanson, another person from Kelsus, worked there. So that's not where we met each other, but we both worked at that company. And after about a year and a half of building a Java app, it was a big enterprise Java app, enterprise Java beans and the whole thing. After about a year and a half, it got to the point where the only features we could add were just tiny, put a drop-down menu here or redo the sort order with this stuff there. But adding a new big feature just became impossible because every time we tried, we would end up breaking everything. And the people that had the capability to add a new feature were constantly fighting fires. They just had no time. The thing was deployed at major retailers, each in their own in-house clusters. So each cluster would be 5 or 6 machines, and then a database and a SAN. And this would be at Lowe's and Best Buy and Sears. And so all the developers were constantly just trying to keep the thing alive. And then when they did try to add new features, they would, the whole thing would break. And similar to your story, we would also see release cycles take forever. So you're going to do a new release. You have a whole release manager who's guiding builds and testing and everything from the point of being code complete for another 2 weeks or even longer before you get the thing. The technical term, I guess, would be hardened and ready for customers. I'm not sure with that company whether a CI/CD pipeline would have helped Dockerize. I think it might have. So a couple of things that I think would have been useful are, one, that we did have unit tests. We did have some test coverage. It was not in a continuous integration server. So I think we lived a lot of our lives with broken tests and just kind of put up with it. And that definitely would account for some of those bugs that would come out of nowhere, regression bugs and bugs making it out into production that made our customers unhappy. And then thus the firefighting and the developers being overly busy. And then the other thing I think that Docker kind of forces people into it, not necessarily, but just the fact that it's a componentized way of deploying, is that if we were doing it with Docker, Docker wasn't available, but if we were, we probably would have tried to structure our services, our APIs in more modularly so that a whole big application didn't need to get replicated across all the machines in a cluster, and then only smaller parts of it needed replication. And I think more modularity would have created a situation where there was less opportunity for changes in one end of the system breaking another end of the system. So that could have also helped us. But I don't know. I think there were other problems at that company that were slowing down the feature velocity, and I would have been a little uncomfortable, honestly, making the argument to the CEO there that doing this was going to just solve the problem completely.
And that's a good point too, because if there's various reasons why projects stall. And the pattern that you just described is so typical, right? Basically, a team gets going, they have great velocity, they add lots of features, it grows and grows and grows. But over time, whether it's a year or two, it becomes this big monolith, and it's essentially a big ball of mud, and it reaches a point where it's now everything is so tightly coupled that making changes to it is very risky, it's very scary, and you get that feature velocity going away. If that's the kind of problem you have, or sometimes there's some process or culture issues going on as well, to have this decreased velocity. If you say, I'm going to fix this by turning on CI/CD, well, that's just adding fuel to the fire, right? You're just now going to go faster with your problems, right? And it's going to make things worse because you're going to feel so bad because it's going to give you so much more insight into all the stuff that's broken. Your deploys are going to fail much more quickly, and you're going to be so in a reactive mode, right? So in that case, definitely probably not a great idea to throw CI/CD to that particular, if you have that particular issue.
Yeah, and just for people listening, I think we did sort of solve that issue in the end, and we did it with something I think that we called the strangle pattern, which is basically we took that big ball of mud and said, let's just move it over here. Let's not touch it. It seems to be working. Let's build other systems when we want to build other features. And that was the way out of that feature velocity nightmare.
Yeah, absolutely. Definitely a typical pattern of how do you move from a monolith to modular services and microservices type approach.
Yep. So I don't know. I have one other story that I think I could tell that's kind of interesting, but did you have any others?
Yeah, I think the various, for me, a lot of the experience has been when feature velocity is an issue, or it comes down to just like, what are the manual steps that you're doing that really could be automated by your tool set. So,
but when we were talking earlier, sorry to interrupt, when we were talking earlier, you were talking about having too many priorities and kind of getting lost, like trying to do too many things at once. And I thought maybe you had a specific company that you worked at or a team you worked with where that was the problem.
Yeah, sure. One of the recent projects in the past, it was a company we were building software in the healthcare wellness space, and a startup company trying to establish itself in a new market. So very much had a need to go fast. So we started off kind of on this mission of building software very, very quickly to meet kind of like the goals that we had as a company for the kind of features that we wanted to get. And there's various people in the company that was their job, right? To come up with what the roadmap should be, what features we need to have, and then basically really push for those things to happen quickly. So that's what happened. So the engineering team builds the code. It's done very quickly. So we know that there is technical debt that's being accumulated along the way, but a very real pressure to deliver features based upon the needs of the company and where it's at in its life cycle. And so as that process continues, we ran into this issue, a natural issue of, as you're going fast and you know that you are accumulating technical debt, you still have the pressure to add additional features because now your product is now perhaps in the marketplace, you have real users using it. Those new users are now exposing some of those real problems from your technical debt. So you have this problem where you have a bunch of technical debt that's causing lots of problems and very real issues that are causing existing users to not be happy. But the business itself has still not evolved to its full business plan. And so the other people on the team are pushing for new features. And so there's this very, very real tension. And for me, in my particular experience, I had to make that trade-off, right? Do I add the new feature to keep the project leadership team happy, or do I fix the bugs that are causing our existing users to be unhappy? And it was never, I couldn't do both, right? Because of resources, I had to pick one or the other. And so that was a very common theme. And so you just end up basically getting into triage mode. And so that for us ended up being very defocusing, just because we didn't have the resources to really fully do what it is that we wanted to do. We were spreading ourselves too thin. We didn't know were we stabilizing, hardening our our version 1.0 of our software platform, or were we building out version 2? And because of that lack of focus, basically we did a mediocre job on both things, and it's very frustrating.
So I seem to recall from talking to you before that particular project did actually it was using Docker, and it did have pretty robust CI/CD pipeline.
Absolutely. So I mean, and that was something that evolved over time. When I first started on that, very little of it was Dockerized, and it was very kind of rudimentary first steps. Over a year, 18 months, we had a very robust, very mature CI/CD pipeline, fully automated, and we had continuous deployment. We had support for actually multiple environments that could be built out automatically by automation software. So we basically had infrastructure as code where we could very advanced technical capabilities.
Sure.
However, that doesn't solve the problem of our fundamental problem of lack of focus. So we could go fast, but because we were spread so thin on what new work we wanted to do, we weren't creating enough new work to really take advantage of this great pipeline that we had.
Right. So that's several examples. And one of them, it was a no-brainer. Put in a CI/CD pipeline in Docker and save yourself a bunch of manual work. Another one, it was, maybe that would be helpful, but there were some other fundamental problems, and the strangulation pattern was what was needed. And then in your final example, it was already there, and you still ran into velocity sort of go to a halt. So obviously, as a business case, this is not a panacea. This doesn't fix everything.
How about for new projects? Is there ever going to be the case that you're going to consider not going ahead and putting these things into place for a brand new project when someone comes to you with the idea?
So this is something that I talk about with Chris a lot, because I think I come from working with a lot of startups where it's not clear what the ultimate value of the software we create is going to be, and we have very little time to produce some software to get a sense of whether it's valuable or not. And the company can't really afford to spend any time not related to doing that experiment, doing the experiment of, do people want this? Do I have product market fit? And I think in those cases, when you're just building software to see if people want to use it and not building software for the long term, it's probably not a good idea to spend much time at all doing automated testing, putting together infrastructure as code. Even using Docker may be overkill in that case.
So maybe it's a conversation with those founders or the money that's supplying the resources that, let's get to this point with the intention of rebuilding from scratch.
Absolutely. Yeah. I can't tell you how many times I've had that conversation. When you have increased your value well enough to attract investors for your Series A, use that Series A to build this right.
Yeah. So basically product market fit is that milestone that will typically get you to that Series A.
Yeah.
So that initial money should be spent on rebuilding the app that you just spent 6 months building.
Right. Yes.
Which is probably a hard conversation to have with an owner.
Yeah.
Because they see it as working.
Right.
Because those other things have not yet caught up to them.
Yep. And the thing is, when you're building an application to be a startup and to get that traction and get that product market fit, it's not just a prototype. It's not something that's completely throwaway code. Real people are going to be using it and depending on it. So that transition between kind of using irresponsible development techniques to using responsible software engineering techniques is going to be tricky. Like you have to make sure you don't make your users hate you through that transition.
Yeah.
Yeah, I think for me the difference is, are you building a prototype or are you building an MVP?
How do you differentiate them?
Well, for me, prototype is something that is very short duration. It's something that has to be thrown together very quickly. You can think of it as a mock-up of what the overall piece of software is that you're building, and you just need to go really, really fast, right, to flesh it out. And it's kind of part of your spec or your requirements, if you will, right? Versus an MVP is something that you actually plan on running. You are going to use it to determine your product market fit. that means it has to be, like, as John said, it has to be reliable. It has to be robust, right?
Yeah.
Like, you're not going to find out if you have product market fit if that thing is falling over daily, right? If users are getting errors constantly.
Right.
So, part of the whole, the answer to the question of, do you start off, when do you do this whole, do you have a robust CI/CD pipeline? Do you Dockerize? When do you do that? A big part of that is like, well, how much is that going to cost you? So if you're a brand new team and you've never done this before and you have to learn along the way, that's a huge investment. But like for us here at Kelsus, like we've already gone through that investment phase. For us right now, starting a new project, spin it up from scratch with a CI/CD pipeline, fully Dockerized, it's just the way we build things now. And it's very natural. And it's not very expensive for us to do. I mean, we can measure that, like maybe it's an extra day or two on a project.
So for new Kelsus projects, you're probably putting all
this and the fact that you said it that way really makes me want to walk back a little bit what I said before, because what I said was really coming from the point of view of not already being so familiar with that and having the tools and techniques just ready at hand. Yeah.
But you guys aren't going to be on every project, right? So the people listening are probably going to be sort of in this in-between mode.
Yeah. So don't use your startup budget to learn how to do this.
But this does illustrate a great point that once it is an investment, right, to learn this stuff and to build in these maturities into your process, because once you've gone over that hump, then starting new things becomes so much easier, and you get all the benefits of this, right? You're now reaping the rewards of all this automation. Your tool set, the tool's working for you instead of you working for them.
I wonder if you're in between startups because your last startup didn't work out, use that time in between startups to learn this.
Yeah,
absolutely.
And I wonder if there's a way for there to be some sort of like, calculation that you can do side by side, right? Here's how quickly you're going to get to market with your prototype. And then, here's how far you probably can get with that. Maybe you can even put some like number of users using it before it starts to hit these problems, and along the other side where it's a slower ramp. But over time, this one's going to be more cost effective than this one, because I think that's, if given something that's predictable over, say like 18 months, and you say, well, 18 months, we're going to be kind of caught up regardless. We're going to be slow to build features early on this side, but on this side, we're going to be quick to own features, but then at some point they're going to catch up.
Well, it's funny you say that, Rich, because we did do a little bit of thought around how much it costs to bring a team up to speed. You can't see this spreadsheet that I'm about to look at, so we'll just talk about some of the numbers in it. And these are just guesses, but I wanted to get a sense of how expensive it is to take a team from 0 to 1 when it comes to learning, not just Docker, but learning the whole front to back of how to make Docker the center of a robust CI/CD pipeline that starts with you developing on your local machine and ends up automatically putting software into the cloud inside a Docker container or multiple Docker containers. So I just thought, okay, imagine devs cost you $100 an hour. Imagine you have 20 on your team, and on that team there's maybe there's 4 projects. Each project has 5 people on it. So you can kind of picture that team. It's 4 groups of 5. And each of them are working on different but integrated software. So this is not a startup. This is just some company that's out there trying to make software. And maybe they're currently kind of stuck in some 2006 to 2008 kind of development practices where they're using a platform as a service, and they're writing in Python or Rails, and they're just pushing to their platform as a service with Git, and it seems to be working okay. Maybe they have some tests, but they're not getting picked up by Circle CI. And the tests maybe are just so that maybe the team needs to learn a little bit more about writing an effective test. So there's a lot they need to learn to go from being a development organization to a software engineering organization. So first of all, maybe each of the people on the team, maybe they need about $1,500 just of plain old training. They just need to go through some training or to buy some online courses or books or whatever. Each of the people need that. So for a 20-person team, that costs about $30K. And then we can also imagine, we're going to have some lost time. We're going to have to pay for some of their time while they're coming up to speed on this. And maybe, I don't know, just thinking about Kelsus and thinking about how long it took for some of our people to come up to speed on all of this, because Kelsus was kind of in exactly this situation a couple of years ago. I would say each one of them needed around 200 hours of work to get this all figured out and to get it into their muscle memory. And we're still adding to it, so there's still new things that we're learning, but just the basic CI/CD setup with Docker, a couple hundred hours. So that starts to really add up, because when you're at a couple hundred hours at $100 an hour, that's $20,000 a person. So then you're talking about $21,500 a person, and for 20 people, that's almost $500,000. That's $430,000 just to do this. So maybe not what you want to take to your CFO. We want to do this, and it's going to cost $430,000. And Chris, you were the one that did this for Kelsus. You joined Kelsus and you brought us into this world. And I think that if you had said, this is what we're doing and it's going to cost $430,000, I would have said, maybe if we can get just the right client to sort of sponsor this, we might think about it. But I don't know that we can afford this. I don't know that we can go from this type of team we are to the type, we can't pay $430,000 for this. We don't have the cash flow for that. At the time, we definitely didn't. So, but we did do it. So how did that work?
Because I didn't tell you it was going to cost $400,000.
Right.
Yeah, and there are a couple. So I think these are all very, very reasonable assumptions, and this is absolutely an investment it's an investment in personal development and growth as engineers, right? To learn these technologies and to bring these things into a tool set. And learning costs money. It's not for free. It's going to take some time to do it. So it is an investment. It is. I think if I did come to you and say and focus on hey, this is going to be a $430,000 investment, that would have been a pretty difficult conversation to have. I can also kind of flip it around too and say, John, do you think in retrospect this cost $430,000?
Yeah, and I think it did actually. So I want to just talk openly about our biggest client and our best partner. They're a company called KBS. They're all over our website. And they're a clean services company. We've been building software for them for about 3 years. I would say that in terms of our billing to them, there may have been a point at which the leader there sort of felt like he got for about $600,000 worth of spend, he got about $200,000 worth of features in terms of what he was used to getting in terms of features. And that sounds awful when I say that. That sounds just like the worst thing in the world. But all of a sudden, now we're in a position where, I can't say that the name of the client that they have as a service company, but it's a very well-known company that we're very excited to be building software for. And we would not be in the position to be able to deliver software to this big company, this big well-known company, if it weren't for the fact that we've put in this investment and we can sort of meet the litmus test of, are you software engineers and do you build stable, big, scalable, real software? And I think maybe Chris, you can give an example of what the client was used to with a little project we did for them and what that was really worth versus what they're getting now.
Yeah, I think there's been a lot of evolution since that relationship started over the 2 or 3 years that we've been working with them. I think in addition to Kelsus doing some growth, they've also grown and matured in their capabilities. So 3 years ago, they were looking at technology in a much different way. They were looking at it as very business-driven, very just-in-time development. Like, what is this week? What is the current business problem, or what's the feature that we want? And we just need to spin it up really quickly. And time is more important than anything else. Not really the sense of we're engineering software, right? We're building software for the long term that's going to be robust, that's going to be maintainable, that's going to be code that's modular, so that we're not duplicating ourselves. And so they have matured in kind of their where they're at and where their head is around, like how they're viewing software development and their technology capabilities. So early on in the relationship, it was very much more of a pattern of, hey, we need to get something out quickly. Doesn't really matter so much about how it's engineered, just it needs to happen quickly. And that works as long as you don't have very high demands, or you don't have too much usage, or it's just not mission critical to the business, right? If it's
right. So to kind of bring that down to earth a little bit, we built an application for them that was a prototype. We did it in 2 weeks, and it was one of their first ever customer-facing applications. It's one that they didn't use internally, one that they wanted to show to their own customers, and it was just a hit. It was just great that the fact that we built that thing so fast, and the customer actually used it, and is still, I think, still using it today. But what about that app? Like, why is it working, and why don't we just do everything like that?
Mm-hmm. And so that particular app, one of the reasons why it was built so quickly is because we had actually been working on a bigger app that was a bit more general purpose, and it was being designed to be more mission critical. Our customer had one of their customers that needed this kind of similar functionality, and so the idea was, can we just duplicate that functionality for this other customer? So one of the reasons why that happened so fast in the 2-week time was it was literally a copy paste of a bunch of code that already existed, right? And then it was just hacked into it or modified to whatever slight differences it needed for the individual customer that was going to be deployed for. And so that worked pretty well, right? It was a single customer, so it wasn't multi-tenant. There's no extensibility to it. It did the one thing and did it well. But one thing we have struggled over time now is how do you actually improve upon this? How do you add to it? Especially when we're still putting so much effort into the mainline system from which that was cleaved. So we have this problem where we can't really update that application all that well without just duplicating all of our efforts, and that's become kind of a very much of a sore thumb that we know that. So it's now coming back to cause problems. So we now have a roadmap to basically bring that back into the fold proper now that we have much more of a platform in place.
Right. So and this is something that just happens all the time where you deliver a prototype that has a lot of value and you deliver it very quickly, and then the customer points at that thing 8 months or a year later and says, why are you able to do that so fast and everything else takes so long? And you just said the answer, right? But it's hard to also say, but yeah, look, we can't do anything with this thing anymore. We can't add more features to it. We began the hour talking about all of these applications that we worked on that have ground to a halt feature velocity wise. That thing we worked on for 2 weeks, and immediately after the end of that 2 weeks, it was already stuck in the mud. There was nothing more we could do with it because of the way we built it.
Yep.
Yeah. Indeed. So basically, I guess looking at KBS and looking at our relationship with them and sort of learning this with them, bringing this style of development to them has been a huge win for them because now they are able to attract a caliber of customer that they were never able to attract before. So that's just, it's very easy to make a business case for that being worth it. For a company that's absolutely not a technology company to now be respected as a technology company has been huge for them. And I think that doing this kind of development and having this kind of capability leads to those types of outcomes. So if you are in it for the long haul, if you're doing something where it's more than a year's worth of, where the software is supposed to live for more than a year, absolutely worth the investment. So I actually want to talk a little bit. We also tried to figure out, on the benefit side, can we actually put numbers to any of the benefits? And are those numbers big enough that you could just take this to your CFO and say, we're going to do this, and here's what it costs, and here's the benefit? And honestly, I think this is a little difficult. And I think that's why we have sort of stumbled around a little bit talking about the business benefits of Docker, because it's hard to put numbers to them. But I did get one out of all the ones we talked about dealing with broken builds or works on my machine type stuff. We've talked about setting up new developers. We've talked about how Docker saves money on infrastructure, because you can have multiple applications across one set of infrastructure now. Of all of those things, the one that is maybe the easiest to quantify and comes out with the biggest numbers is actually the broken build, or it works on my machine, loss of team time. Because in a company or in a team where they're hurting and they have a lot of broken builds, they just like whenever your team is not working on new stuff, you are just churning out money for nothing. So if imagine you have those 4 teams that we talked about earlier, and each of those teams loses 4 hours every time a build is broken, which is all of the people lose 4 hours. It's very, very easy to have happen. And then imagine that each month, each of those teams has 3 builds break. The total cost of those, assuming $100 an hour per developer, is right around $300,000. So it's not quite as high as our $430,000 just to learn all this stuff. So in year 1, just on broken builds alone, you don't recoup your investment, but you get awfully close. And since you don't have to retrain $430,000 in year 2, boom, if you've got software that lasts 2 years, you've already paid for it. So maybe not the best business case for your CFO, but it absolutely is a business case. Absolutely, you can, with confidence, if you're dealing with broken builds, say, Docker is going to fix this, Docker is going to save money, CI/CD pipeline is the way to go. I wish I could do better. I wish I could say, look at this 2 million in savings that you're going to get, but this is not bad. 2-year return on investment is not bad.
I think I might have a narrative that is a little bit meta, but
Sure.
I think it plays. And it's that in tech, just like in life, right? Some of the best investments are preventative.
Mm-hmm.
And it's very, very hard to put a finger on any one of those granular benefits.
Right.
Like in order to be healthy, you have to do a lot of work. And if someone says, how do you feel 3 years after becoming vegan or paleo or whatever, or starting the gym? You just say, my life just feels better. Like I know it's better, but I can't tell you why.
Right. Yeah.
But like the end result is maybe a longer life.
Yep.
Right. And so those things are very hard to say, but I think that you can rationalize that with this too, is like doing these things is preventative, and it'll be hard to say that you prevented a problem because the problem never actually happened.
Right. Yep.
But through experience, these problems always happen, and
Yep.
you're having less of them than our other clients and stuff like that.
Yeah. And it's hard to prove a negative. And these things are vitamins and exercise.
Yes, that's exactly right.
We've become blinded to what we're used to, right?
Yeah.
So using your example of like exercising or going vegan or whatnot, right? If you're not doing that, then there's very real repercussions, right? Maybe it's harder for you to get up the stairs. Maybe you're more tired. You're more lethargic. Maybe you don't sleep as well. But these are all things that you're just living with, right?
Yeah,
and
that's the
and
thing,
you can't. You're
living with
not measuring the cost of that
because it's just life.
You're just used to this. It's just the way it is. And so I think it's the same thing with development, right? Like broken builds. That's just part of life. That's the way it goes, right? You become immune to it. You're blinded to it, and so
it's factored in to your
Right.
daily routine.
Another thing we looked at was just, what is that infrastructure savings? I think you'd have to have a pretty big company with pretty huge installation to really wow your CFO with the infrastructure savings. Just sort of off the cuff, I thought, well, what if each of your 4 applications costs $1,000 a month if you do it each with its own complete set of environments, each with its own staging and production, with its own EC2 instances in AWS? Imagine you could have 60% reuse of those machines. So, you could put 1 and a third basically application onto each of the EC2 instances that you have. So 60% savings would take an annual cost of $48,000 down to about $28,000, which is awesome. Save the money, use it. But again, it's like these incremental costs, these incremental savings, and they start to add up. Another one, new development setup. So imagine it takes a developer about 20 hours with the old style of doing things to get up to speed. It's like, hey, welcome to the team. Yeah, I think there's a README somewhere. I don't know if we've updated it in a while, but go on there and check it out and try to get your development up to speed or your machine ready for development. And Steve over there is the last one that did it. So if you're running into trouble, talk to Steve. And inevitably you run into trouble. And of course, the first thing you run into is installing the database on your machine, because that never works. And so then, 20 hours later, you're ready to develop. If you add 4 developers a year on a team of about 20, that sounds about right. Then that's around $8,000 that you lose to development setup costs. So again, another small but fixable loss of money.
Yeah, and the one thing that's not factored into that is just the time it takes to prepare all the documentation necessary in order for someone to do that, right? To set that up.
Yeah, sure.
So, I mean, there's many hours there. Like,
not that many though. Remember, because you did it once and nobody ever updated the document.
Yeah, and then the other thing too on the infrastructure is even though the actual like hard cost there, maybe it's not so much of a big improvement, but the consequence of having less DevOps personnel to handle that, right? It's so much easier to maintain a cluster of 5 EC2 nodes and to harden those, lock them down, keep them secure, patch them, than it is to have 5 separate Beanstalk apps with 2 nodes each. And it just requires a lot more maintenance and care and feeding. And those are very real hours that are ongoing, and those add up a lot.
Yeah, and we haven't put numbers to those, but you absolutely could. And then another one that we didn't put hours to, but that kind of occurred to me because it relates back to a conversation we had before about how doing this lifts your whole team's skills. There's that mythical concept of the 10x developer. And so if you have a team of 20, maybe have 1 or 2 10x developers on that team. And those people are always, in the old style of doing things, those people have a tendency to get pulled into solving hard issues inside the infrastructure where the code is running because they're the only ones that understand how to do that. As soon as you lift the rest of your team, now all of a sudden you haven't lost those 1 or 2 10x developers productivity, and you might be able to quantify that in some way. So the rest of the team, maybe they go from being 1x developers to 5x developers, and those 2 10x developers stay 10x. That's a huge, if you could quantify that, if you could put numbers to it, you could add this to the growing list of benefits that you get from this.
You might not even have to put numbers to it because HR departments try to build culture in a lot of different ways. And if you're creating an opportunity for employee growth within your company, that has to have a positive impact on culture. Yep. And so, maybe it's your Glassdoor review, right? Sure. Those types of things will elevate if the people are being challenged and recognizing that as a part of this organization, I'm a better developer, which means that either I can improve with a better position here, but also just my career in general. And as a result of being at this company, that's why I learned it, because otherwise, when would I have had the time?
Right.
Absolutely. Who wants to work at a team that's using 2008 right processes and tech stack, right?
Yeah.
Like it's 2018. This really is an investment, and like we've talked about, the cost here is that this is like the initial investment. You're not going to be paying the same price for subsequent projects. So you really pay that investment once, and then you get to reap the benefits going forward, right? And so again, it's the whole elevate. Like you're basically, it's kind of the difference between like making the choice to continually do something manually or buying a tool that will save you 20 hours of time, right? And yeah, it costs money to buy that tool, but once you do that, now you own it, and now you get to take advantage of that going forward.
Yep.
Right.
So really, in any case where you have long-term software that you're going to have in production and maintain, and the desire to continue to build new software to add to your collection, your suite of software, if that time horizon is at least a year, but probably like 18 months or longer, do this and convince anybody that might not want to let the team spend this extra time, convince them that it's worth it, because it absolutely will be. The only time it's not is when that time horizon is super short and you don't already know how to do this. All right. I think we're good. Thank you.
Great. Thank you.
Thanks.